Hello everybody, this is Mr. Shaban and today we're going to have another lesson in the chemistry section. Our unit of today's lesson is called Energy Changes. First lesson in this unit is going to be mainly about the change in energy. The learning objective of today's lesson, by the end of the lesson you should know an exothermic reaction is one in which heat energy is given out. Burning is an exothermic reaction. Burning is a reaction in which substance combines with oxygen. When substance combines with oxygen, we say that oxidation has taken place. So mainly the keywords of today's lessons are exothermic reaction and oxidation. We're going to discuss these two reactions and we're going to know what are the kind of the chemical reactions. In today's lesson, we're going to discuss mainly the burning process. Burning process is a chemical reaction in which a substance is reacting with the oxygen found in the air. So burning is a chemical reaction in which a substance combines with oxygen which is found in the air. The substance that combines with oxygen is called fuel. So I want you to think about your cook. It has a natural gas found in the cylinder. So this natural gas burns in the presence of the oxygen of the air in order to make you cook your food. In the same way, if we're doing a barbecue outside, so we're burning coal, we're burning wood. All of these are called fuels because all of these have energy stored inside them. So the fuels store energy in the form of a chemical energy. When you burn it in the presence of oxygen, actually you're changing the chemical energy into heat energy, into light energy, sometimes into sound energy. Charcoal, wood, coal, natural gas and oil, all of them are examples of the fuel. So combustion is what we can call a burning process or a burning reaction. Combustion is another term used for burning. Combustion is often a fast reaction. So I want you to know that in chemistry we're not calling burning reactions as a burning reactions, but we rather call them combustion reaction. So combustion reaction is a reaction in which a fuel is going to react with oxygen in order to produce energy. So during combustion, the chemical energy stored inside the fuel is easily going to be changed into heat energy, light energy, and sometimes, as we said, sound energy. So let's discuss burning coal. So when we burn charcoal, it reacts with oxygen in order to produce heat energy and light energy. But as a result, carbon, when it reacts with oxygen, it's going to combine together and change into carbon dioxide. It means one atom of carbon, like the black one, is going to be attached with two atoms of oxygen. That's why we have written di. Di represent two. So carbon combines with two, oxide refers to oxygen. So when charcoal burns, the oxygen and the carbon atoms rearranged. So you're going to have a rearrangement, or you're going to change the position of the oxygen to the carbon. And you're going to make a bond. As you can see over here, the oxygens were attached together and carbon was apart. So carbon came in between. A rearrangement has happened, and then after the rearrangement a bond has taken place. So this bond has attached the three atoms together in order to build one unit. So new bonds are created to form molecules of carbon dioxide. When this rearrangement happens, energy is given out and the temperature rises. So if we have any reaction where the temperature is going to increase, this is going to be called an exothermic reaction. So an exothermic reaction is a reaction that gives out energy. I want you to look over here. Exo means exit, comes from the word exit. So exit means going out. Thermic means heat. So heat which is going out. That's exothermic reaction. In this reaction, we can state that carbon along with oxygen are called reactant. So carbon and oxygen are called reactant because they are found before the arrow. On the other hand, carbon dioxide is found after the arrow, so the carbon dioxide will be called product. Good. So you might have a question asking you to figure out which is the product in this word equation. You need to know that whatever is found after the arrow is called product. So carbon dioxide is a product, while oxygen and carbon both are called reactant. Okay, another example over here we have the hydrogen and oxygen. You know, hydrogen is also can be considered as fuel. In RGCSE, we are teaching them how the scientists are trying to use the hydrogen more frequently, as it can be used as an emission-free fuel. So when the hydrogen is burned in the presence of oxygen, okay, in a combustion reaction, it's going to provide a huge amount of energy and is going to change into water. So the atoms of the hydrogen are going to rearrange along with the atoms of the oxygen, while you have one oxygen in between and two hydrogen atoms, one on each side. This is representing water molecules. So rearrangement along with bonding has taken place. So the chemical energy found in the hydrogen are changes during the combustion into sound, energy, light, and heat. Because when we burn hydrogen in the presence of oxygen, it makes a pop sound. Something like that. So the sound and heat, light, all of them came as a result of burning the chemical energy stored inside the hydrogen. Perfect. We have another example, magnesium and oxygen. When we burn the metal of magnesium in the presence of oxygen, we're going to make magnesium oxide. So magnesium is a molecule which consists of two magnesium atoms. Okay, one should be apart from the other one, so it's a small mistake. This should be apart from this, and then oxygen, both of them should be together. When the magnesium and oxygen react together, the magnesium is going to, one magnesium is going to attach with one oxygen, one magnesium is going to attach with one oxygen. So here we should have two of them apart from each other. That's a mistake. One more time. So each one is going to hold one oxygen atom in order to make magnesium oxide, and the energy, chemical energy, changed into light energy and heat energy. Let's discuss the oxidation reaction. As we have discussed combustion, we have discussed the exothermic. Right now we're going to look at oxidation reaction. What is the oxidation reaction? Oxidation reaction is a reaction that takes place between a substance along with oxygen. So when a substance burns, it combines with oxygen. A new substance is made, and this substance is going to be called oxide. As you have remembered, we have taken the magnesium. When we burn magnesium in the presence of oxygen, it makes magnesium oxide. When we burn carbon in the presence of oxygen, it makes carbon dioxide. So the term oxide represents a substance that has combined with oxygen to produce a new substance. Any reaction where a substance combined with oxygen is going to be called oxidation reaction. So the oxidation reaction is a reaction at which the oxygen will be combined with another substance. So combustion is an oxidation reaction. Good, because we tend to burn the fuel in the presence of oxygen to produce an oxide. On the other hand, when iron rusts, it combines with oxygen from the air. Iron oxide is formed, although rusting is a much slower reaction and less vigorous than combustion. So you need to know that rusting is another way or another reaction for oxidation reaction, but it's a very small reaction, slow reaction. On the other hand, we have another lesson, more exothermic reactions. The lesson objective of this particular lesson would be when a metal reacts with water or acids, heat energy is given out. So that's an exothermic reaction. And the reaction of a metal with water or with an acid is called an exothermic reaction. So we're going to look at the rearrangement and how the rearrangement takes place between the elements, and how these elements are going to make a new bond in order to produce energy. So potassium is a metal, as you can see. It has 2 atoms. Water has oxygen along with hydrogens. When potassium is reacting with the water, is going to produce potassium hydroxide along with hydrogen. So over here we have taken, for each potassium atom, it has taken oxygen and 1 hydrogen, 1 oxygen, 1 hydrogen, leaving one hydrogen out. These 2 hydrogens have been collected in a molecule called hydrogen, while the potassium has attached with oxygen along with hydrogen. Before the arrow, we tend to say we have a reactant, and after the arrow we have products. So water is made of a molecule which consists of hydrogen and oxygen. In this reaction, as you know, the bonds has taken between the potassium and the oxygen along with hydrogen from the water, and 1 hydrogen atom from each water molecule were taken out to make a hydrogen molecule. So that's a reaction between the metal along with the water. And as we have said, these are the reactant and these are the products. Another equation, it's between the magnesium and hydrochloric acid. When magnesium reacts with hydrochloric acid, is going to make magnesium chloride along with hydrogen. So magnesium is going to attach with the chlorine and hydrogen will be given off. And over here we have magnesium and hydrochloric acid. These are going to represent the reactant, while magnesium chloride along with hydrogen, these are going to represent the products. So I want you to know that when we place the magnesium in the hydrochloric acid, you're going to find a change in the temperature. At the beginning of the reaction, we start with 18 degrees Celsius. That's the start temperature. When we end the reaction, at 42 degrees Celsius. It means that the temperature has changed from 18 up to 42, and this is enough to give you a clue that this reaction is an exothermic reaction. In today's lesson, we have discussed the combustion reactions, and we have said that combustion reaction is a reaction in which a substance reacts with oxygen or burn with oxygen in order to produce energy. And we said the meaning of exothermic reaction is a reaction in which an energy is given out. And we have discussed the oxidation reactions. It's a reaction where the oxygen combines with another substance to produce oxide. And we have taken some examples of exothermic reaction. I hope you have enjoyed today's lesson, and see you next time.